general fitness functions. Um, what does that even mean? And let's talk about the concept of fitness functions. We'll talk about some examples of fitness functions, and then we'll talk about how we could actually measure it in our applications as well. So we'll talk about these. But before we do, one of the interesting aspects of what we do in general is we learn a great deal from other fields. And this is one of the powerful things that we do. There is clear evidences of this happening in our field. If you think about the design patterns, if you read the Gang of Four design patterns book, they talk about the design patterns coming out of the observations and learnings from the patterns in building. And when you look at building, the way public buildings are built, or churches are built, or even houses are built, you might talk about what kind of style is used to build a particular building. And in a similar way, we can talk about patterns which are similar to solutions used in different contexts, different scenarios. So in that sense, we learn from other fields. In a similar way, there's a lot of things we can learn from other fields, and we bring in those ideas into our own field so we can get better. Now, from that point of view, what are the things that we can learn from maybe construction business? What are the things we can learn from medical business and so on? Now, let's say I go to the doctor's office, and when I go to the doctor's office, one of the things they ask me is, "How are you doing?" And I always say, "I'm doing great." And then I kind of think about this. Why am I at the doctor's office? I'm doing really, really great, right? But that's a courtesy. They don't really expect an explanation. And then uh, they want to know how I'm really doing. And the doctor's office looks for five things in general. So the first thing they do is they ask me, uh, "What's your height?" And I tell them what my height is. And you may wonder, why do they care about my height? Well, as people age, they become shorter, and they want to know if I'm losing my, or a person is losing their bone density, right? That could be a concern. Um, they ask me what my weight is. Uh, this is inversely proportional. As you get older, I suppose the weight seems to be keep going up. So we want to measure that. So they look for height, my weight. They ask for my temperature. What's your temperature right now? So they measure my temperature. Then they are interested in my blood pressure and to see if the blood pressure is normal. Then they look for my pulse rate. And they could even go further. They may look for my blood oxygen level. So that's six things rather than five things. So five to six things they look for. Now, why? Why do they look for these five or six different things? It turns out if my temperature is in a certain range, that means I don't have a certain type of problems. If my temperature is running high, they may say, "Gosh, you are running a temperature. What's going on here?" As it turns out, the doctors know that if the temperature is between this and this range, it could be a certain type of disease or infection. If the temperature is between this and this range, it could be a different type of infection. So they may, narrow down the type of problems that may exist based on the temperature. It's really weird to think about it because we are introduced to this world and all this information as we go around, but a lot of times we don't always spend the time asking, how long have you been doing this? And it turns out that 150 years ago, there was no standard. Humans did not know what a standard body temperature was. And then eventually they figured out, hey, looks like Most of us have similar body temperature. What a concept. And they started measuring it. And they got it wrong by 3 degrees, actually. Until they revised it, now we kind of know what the temperature of a body is for a person who is relatively healthy. So it's interesting to see that you can look at a temperature, blood pressure, pulse, oxygen level, height, and weight, and determine if a person is doing well or needs some medical attention. So, in other words, we have a way to check the health of a person, relatively speaking. But then the doctors may say, let's measure your cholesterol number, let's measure your blood glucose number, and then they can tell a little bit more about my health. So, in other words, when you ask the question, how are you doing? The answer is, let's see what the numbers tell how I'm doing, right? So, similarly, I fly a lot. I'm almost on an airplane every week, if not every other week. And when I'm flying domestic, I almost always sit by the window seat because I don't want to be disturbed. I open my laptop, I want to continue to work, I don't want to be bothered by people coming in and out. And when international, I usually take an aisle seat because then I can stretch my leg, walk around a little bit. But when I'm sitting by the window seat, I'm always curious. I look out the window and I would see the pilot walking around on the floor. And usually the pilot has a little flashlight and they kind of point and look at various places. It's kind of funny to watch the pilot doing this on the ground. And they'll be looking for, leaks and maybe a few things here and there. And a pilot goes around the airplane checking things. They walk around the wheel, and then they come up into their seat, and then they go through a set of checks. They keep flipping switches, and then they see if things are working properly. And then if things are not working properly, then they have to call for help, and then they have to sign off saying, "I went through the flight check and everything is great, and we are ready for takeoff." Right? And until they close the flight plan, they cannot close the door, and that's a requirement in the flying industry. So again, that is something that's a standard practice because they want to make sure that we don't get into trouble when the flight is, up in the air. So these kinds of experiences, one of the books that I really enjoy reading is this book by Atul Gawande, and the book is called. Let me see if I can bring it up here. So the book is called Checklist Manifesto, and Atul Gawande talks about he's a surgeon, and he's a surgeon, and he looks at the practice that they have, and he finds out that there is there are patients who come into the hospital and they are told it's a relatively minor outpatient surgery. Show up at 7 o'clock. We'll get you admitted. We'll give you an anesthesia. We'll administer the surgery. You can be home for dinner. Well, the person shows up at 7 o'clock, and by 10 o'clock, the person is in emergency. And he was like, how does this happen? How does a person who comes for a very minor, regular procedure doesn't go home, but instead is an emergency? And he starts analyzing a lot of these surgeries, and what he finds out is that a patient is extremely allergic to a certain type of medicine. The record shows that. And guess what they did? They gave exactly the medicine the patient is allergic to. And he's like, how in the world this could happen? Well, the reason is the person administering the medicine doesn't go through the information and ends up really giving the wrong medicine. So his question is, how can we reduce the rate of error in surgeries? Because you want to really have more successful surgeries, and you want patients to recover sooner. That's good for everybody, including the patient. And how can we really make that happen? And he realizes, so he looks up to the pilots. And here's a doctor who says, I want to improve my surgery. I'm going to see what these pilots do. And he realizes one of the things pilots do is they have a checklist. And the pilots have a checklist, and they sit down there and they take their checklist and they go through and make sure they have checked on each one of the items to verify. We check this, check that control, check that device, that's working, and yes, I've taken care of all of those. And so he says, what if we have a checklist in the medical surgery, and if we go through the checklist before a surgery, then will that improve the practice? And so he goes around to hospitals and says, we are going to have a checklist. Now, we live in a beautiful world. When you suggest a change, the response is, why don't you take a hike? We're not going to do it. So there was a huge amount of resistance. And the hospitals were like, heck no, you're not going to come and tell us how to do our business. We are awesome. But you're not. Your surgery rates are not great. There's a lot of people who are going to emergencies. But no, willingness to change is hard. Resistance to change is high. But he starts really doing this in his own hospital. Gets buy-in in a few different hospitals. They start doing this, and they notice a decline in the rate of error. Things are improving. And he starts publishing that information, and more hospitals begin to say, yeah, we'll adapt, we'll try, and then that becomes more of a widespread standard. So this is a very interesting book to read. You read the book, you realize that the journey that he had to go through to identify the problem, to identify the solution, and then to take the time to really implement that solution and get it accepted. But this makes you think, if the medical field has a checklist to measure the health of a situation, an operation, surgery, if the doctor's office has a health check, if the airline pilots have a health check, if I ask you, how is your architecture? You can tell me our architecture is great, but how great is it? Is it doing great? Is it deviating from what it should be? Is it something that could be turned around for better? How could we possibly, make comments on that? So this is where the question you want to ask is, how well are your architectural goals being met, and how are you achieving them? So sometimes you may know of concepts. You may subconsciously know those concepts. You kind of do things not because you deliberately know this is good, but you do things because somehow that worked. But maybe you didn't really spend time thinking about it. That was the moment for me, like an aha moment for me, when I was reading this book. I was reviewing this book before publication, and as I was reviewing this book, my good friends Neil Ford, Rebecca Parson, and Patrick Kua, they used a term in that book called fitness function. And the minute I read those words, I jumped out. I said, whoa, that's amazing. Now I can put a name to something that I knew, but I did not really spend time thinking about a lot. So this gave me a nomenclature. I wrote the review for this book, and that's exactly what I said in the back cover of this book. Is that these three people gave me a nomenclature for something that is so fundamental. Sometimes you don't even realize it, but the minute you give a name for it, you think very differently. So they call it a fitness function. So what is a fitness function? A fitness function is is really a function. And when you use the word function, don't think of the word function as public void main kind of a function, right? That's not a programming function. A function as in a formula, for example, right? So it's a function that allows you to think about how close you are to meet a particular goal that you set out to. Like, for example, I go to the doctor and the doctor says, hey, you need to really think about your health. If you don't think about your health, you could be in trouble. And I'm like, so what do you want me to do? You need to really bring down your bad cholesterol number down. And I'm like, okay, so what should the number be? And the doctor says, your number is this. This is a good range. So your mission is bring your number to that number and get back in 3 months. So you're like, okay, I'm going to eat better. I'm going to exercise. I'm going to get some sleep. And let me see how my cholesterol number is. Well, 3 months later, I go back and say, what do you think? And the doctor is like, okay, it's improving, but it's not enough. Continue to exercise, continue to eat better, and then maybe as time goes on, they say, swallow this pill also. And we want to bring down your cholesterol number. Then I go back and the doctor says, here's the good news, the cholesterol number is within the range. Whatever you're doing, keep doing, because we want you to stay in that number. That's a fitness function. So my cholesterol number is a fitness function, right? And the doctor says, if your cholesterol number is really bad, you're in trouble, bring it down to a proper number. Now, on my projects, I normally tell my developers, when you write code, I'm going to look at something they all dislike, and that is called the code coverage. Now, I'm sure you've had people ask you this question, right? They ask you the question, what is a good coverage number? Have you heard people ask this question? Let me translate this to English. I did not write any tests. How can I get away? That's what it really means in English, right? Because if you write tests before you write the code, and you write minimum code to make the test to pass, can anyone guess what the code coverage will be? 100%. Because you're not writing any code until you write the test, and you write code minimally, right? Then we don't talk about code coverage. But here we are saying, I wrote the code, but you want coverage. What's the minimum number I can get away with, right? And this is where this is called finding excuses. We don't want to do the work, we want to find excuses. And we do this a lot. Now, what should be a good coverage number? I got a good friend of mine, Stuart Holloway. He's got a brilliant talk. His talk is titled, I love this because his talk says, how to fail with 100% code coverage. I love that talk, right? You can have 100% code coverage and you can still be failing. That is so true. I often say that code coverage is like a cholesterol number. So code coverage is often like the cholesterol number. So what do I mean by that? If it is bad, we have a problem, right? So you go to the doctor says, oh my gosh, your cholesterol number is so terrible, you better get your act together, otherwise you're going to be in trouble. If it is good, there is nothing to celebrate. I don't go to the doctor and say, doctor, can we have a party called Great Cholesterol Number Party? Right? Can you give me a certificate? I'm awesome because my cholesterol number is good. The doctor's like, get out of here, right? So there's nothing to say. This is the sad part, right? You complain, you feel bad when the number is bad, but you don't celebrate when it's good. You don't say, hey, can we celebrate next weekend party of good cholesterol number? It's like, go get your work done, right? So code coverage. If your coverage is bad, you got something to worry about. If your coverage is really good, you just don't have that problem. Go look for other things you need to worry about. Now you say, but why would you look at coverage? What's the reason for it? And I am waiting to be proven wrong. I stumbled on this accidentally, and I was not expecting this. But this was like a light bulb moment for me. And that is when somebody tells me the code coverage is poor, I have never told them, your coverage is poor, write a test. Never happened. Which is the strangest of things. They come to me and say, hey, the code coverage is bad on this code. I better talk to you about it. Because if I tell you, you help me, And I follow this rule, right? It's called the rule of three. So the rule of three in my team, right? Rule of three is rule number one: do it. Just do it. Don't give excuses. Just do it. And you say, you know what? I don't know how to do it. Ask for help. You don't know how to do it? Just ask for help. Hey, I don't have a good coverage here. What should I do? Well, I didn't ask for help. What should I do? Get yelled at. So, very simple, right? And they don't want to get to stage three because Venkat is yelling and screaming. I better go to him and say, look, dude, the code is not having good coverage. Now let's work together. And when I look at a piece of code, I've never told people you should write a test because the coverage is poor. So when they come to me and say, hey, the code coverage is poor on this code, what should we do? And my first question is, let's take a look at the code. And the minute we look at the code, I'm asking, oh, that code is calling this particular function on this object. Do you know if we should call that object or should we depend on an interface? Oh, that function is really long and it's doing several things. Do you think it would help to break that function into smaller functions? Oh, that function loop has an inner if. Do you think we should restructure it? And all of a sudden, we are talking about refactoring the code, not about writing the test case. And the programmer is like, oh, good idea. I didn't think of it. I'll get back to you. And they come back and say, I worked on it. The code has been refactored. The coverage is good. Thanks for your help. So, what I really stumbled upon is this, and that is show me a piece of code with poor coverage. You have shown me, what can use some refactoring to improve the design. And this is the reason why I look at code coverage. I don't look at code coverage because I want to write tests. I look at code coverage because the code coverage, it's like this, right? We are all nice people, I know that. But 6 months ago, as I traveled, somebody said, I'll pick you up and drop you at your hotel. And usually, when people say this, I'm very, very humbled, very happy. It gives an opportunity for me to travel with somebody. I can talk to them while it's happening. But this particular case, this person said, I'll give you a ride. Like, that's great, thank you. And I go sit in the car, and the person starts driving. And guess what? As soon as the person starts driving, the seatbelt indicator said ting, 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 ting. And I'm like, whoa, the seatbelt indicator seems to be dinging. So I said, hey, looks like your seatbelt indicator is dinging. And his response is, yeah, that stupid alarm that keeps doing that. We get to the point where we no longer hear this anymore. And imagine what happens. You ignore this. Like the smoke detector keeps beeping, and like that stupid smoke detector, I don't want to hear this. The seatbelt indicator, that's stupid, I don't want to hear it. I actually worked with the team, and one of the guys said, the continuous integration kept failing, stupid thing. I said, what did you do? He said, we turned it off. So these are indicators to draw attention to you. A code coverage is an indicator. It's an alarm. It says ting, ting, ting. And you say, hey, what's the problem here? Let me take a look. That's the point of these metrics. They're not there to punish us. They're not to tell us that we are bad. They're just simply saying, hey, can you look at it here? I want to know what's going on. And you look at it, it's like, oh, what's this going on here? So show me a piece of code with poor coverage. Show me what can be refactored to improve the design. And to give you an example of this, I'm currently consulting with a company, a financial company, and my job with them as a consultant is to pair with people and improve their automated testing. I work with backend developers, front-end developers, testers, And this was about a month ago. I got a email from somebody saying, "Hey, my boss said I need to schedule time with you." I'm like, okay, so let's meet. So we connect on Zoom and we are talking. He said, "Who are you?" "Oh, I'm a person who is writing Angular code." I'm like, "That's awesome. What do you want to talk about?" "Well, I don't know who you are, but I my boss came around and looked at the code. There was a poor coverage, and he said, 'Go talk to Venkat.'" I'm like, "Who the heck is Venkat?" "Well, here's the number. Go call him." "So here I am. What do you want to do?" I'm like, "Okay, so you came to me because your code coverage is poor." They're like, "Yeah, so let's look at the code." So we are looking at the Angular component, and here's a function. And when we started looking at it, because he wants me to look at it because the coverage is poor. And the minute I looked at the components function, I said, "Hey, let's talk about this function." In this function, and you know what? This function was about 10 lines long. Not that it was like 100 to 200 lines of code, right? 10 lines long. And we are looking at it together. And then I said, "Oh, looking at this function, you are getting this financial information, and your code says, if this is true, do this." And he's like, "Yeah, yeah, that's what I did." I said, "What if that particular property is different?" And there's silence in the meeting, right? And he's looking at it, he's thinking about it. And then he says, "You know what? I never thought of that. You just found a bug in my code." I'm like, "Okay, do you want to write it down?" He's like, he's writing down, "Found a bug in the code, we need to fix it." So now we are looking at a piece of code, we found a bug in it. But why did we look at that code? Because a boss said, "Coverage is poor, talk to Venkat." So it's not a punishment, right? It's not like, "Oh my gosh, you're bad, you're writing code without test." We didn't even talk about testing. Oh, what if the scenario is different? There's a bug. Second thing is, well, within this function, you're performing this logic, but when I look at this code, I'm finding a hard time understanding this 10 lines of code because I'm reading through this and suddenly there's an if, there's a bunch of code. What does this block of code do? Oh, it does this business logic. What if we take that alone and write it as a function that says, "Does this business logic?" Then in this code, you're just calling that function. How would that feel like? Oh, that would make it easier to read. Okay, let's jot down, let's do that refactoring. And then after about 20, 30 minutes, he says, "You know what, let me go work on these and I'll get back to you." And the next thing you know, he's sending me an email saying, "Thanks for that help, that was very helpful. I'm working on this code. As I started refactoring, I was writing a few tests on the refactor function. My coverage is now 100%. I don't need to talk to you anymore." So a lot of times, it is just that. So I use code coverage as a fitness function. And I use code coverage as a fitness function because when it says ding, 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 I take a look at it. I was like, why is that making a noise? What is it drawing attention to? Oh, there is a design improvement I can make. And so I use this as a way to improve the design rather than trying to feel bad that our coverage is not good enough. So this can be a nice way to look at things. So a fitness function is a function, a formula, an observation that can help you to know if you're closer to a particular design goal. Let's think of another example. I had a client where they found a performance problem. So they have an application, they are performing a certain user, driven, execution. User come in, enter some data, clicks on a button, does some stuff. That was taking a lot more time than it should. And guess what? This was in sprint 7. And they said, "Hey, this is unacceptable. This is really, really poor performance. We got to make this better." So they took 2 developers and they said, "Go improve the performance." And the 2 developers spent 3 weeks on this code. So you can imagine how much time and money was spent on it, right? They spent 3 weeks on this code. And after a lot of effort, they brought the performance down to the acceptable level. And this was in sprint number 7. So now they were in sprint number 30. And guess what they found? Performance problem. And they're like, "Oh, this particular feature is taking way too much time to execute. We got to improve the performance." So now they're talking about how do you improve performance. And as they were talking about it, 2 developers are like, "Excuse me, we kind of vaguely remember working on this. That, has it ever happened? You look at a piece of code, I kind of remember working on it. I don't know if it's true or it was a dream. And you look at the version control, it has your name on it. Oh, it looks like I worked on it, right? We don't remember the details. I kind of vaguely remember working on this. It's fair because you don't remember all the details, right? And these two guys are like, we vaguely remember working on it. Really, when? I don't know, maybe a year or a year and a half ago. And they're like, okay, so do you know how you fixed it? No, but we remember working on it. We didn't like it, we didn't enjoy it. Well, guess what? You both are lucky. It's yours now again. So those two guys are spending 3 more weeks trying to find out. And as they were digging into it, one of the persons said, wait, we improved the performance. Why in the world are we doing this again? And the next question is, who broke it? And that leads to the question, when did they break it? And what they found was right about sprint 15, somebody added a feature and touched the code. And what's really funny about it is, for about 15 sprints, this code has been broken. And nobody bothered to report that and find that out until somebody said, this is awful, doesn't work properly, let's go fix it. Question, what is the lesson from this experience? Regression is not proper. Anything else? The lesson is write performance tests before improving performance. Here, let me put it in different words. If performance is really important, write a test for it first. 2 reasons. If you write a test for performance, what are you going to do? Hey, this should be fast. What does that mean? What does fast mean? Okay, let's write a test for it. Given this number of requests, given this number of users on this kind of system, it's got to complete within this amount of time. Is that acceptable? Is it reasonable? Is it useful? I'm not going to make the decision. I'm going to bring the people who can help me make the decision. I've got business analysts, I've got domain experts, and we are talking about it and say, yeah, this is reasonable, this is acceptable. Now let's put that into a test. And when you put it into a test, what happens? Every time you modify the code, your unit tests are passing, but I'm a performance test passing as well. If my performance test is not passing, what does that mean? It doesn't matter that the code is working. It doesn't meet the criteria that's been set. So you want to write a performance test. The performance test is a fitness function. Because you're saying, in my system, one of the criteria is the performance is within this particular range, and I want to know that goal is met and is being continuously met. I'm going to turn that into performance, into a fitness function. So your code coverage can be a fitness function. Your performance test can be a fitness function. What else can be your fitness function? So many things can be your fitness functions, right? For example, what if your organization has an SLA where you need to provide a certain response time? And if your response time is not good enough, that's not acceptable. That's a fitness function. What if your organization has an SLA for availability? Certain amount of systems must be up and running and be available all the time. That's a fitness function. Because you want to know when you're deviating from it. And if you're deviating from it, you want to bring it back and you want to know that. That becomes a fitness function. So a lot of these are fitness functions, but some of them are design related fitness functions. Let's talk about an example of a design related fitness function. I want my function's cyclomatic complexity to be less than a certain number. That's a design related fitness function, right? Because I'm going to run tools like Plato or PMD, or Radon for Python. And if any of those tools tell me my code is more complex than it should be, I want to fail my test. That's a design related fitness function. I want to write my unit test and run them. That's an automated testing related fitness function. And I want to know that a certain number of servers are up and running. My database is up and running. My request is being processed within a certain amount of time. That's an operational fitness function. An operational fitness function is very critical because why am I writing software? Put into production and deliver it. DevOps, right? And if my operation says your requests are too slow to process, your servers are failing all the time, that's an operational fitness function, and I want to monitor it. Likewise, we can think of architectural fitness functions. So, what are architectural fitness functions for me? An architectural fitness function is, from the architecture point of view, you want to maintain a certain constraints. And you want to know that your application is meeting those constraints. If you're an architect, whether you're an architect by role or by title, I don't care. If you're an architect, if you're a team leader, if you're a senior developer who fills that role of architecting rather than being an architect, what do you want to do? You want to draw up rules, constraints in your application. And you're telling developer, when you're writing code up here, that code shouldn't breach through the controllers and talk to the service directly. I don't want my controller to talk to the repository directly. And you said, that's what I want. Now, there is always, I'm of the firm belief, programmers are not writing bad code because they're malicious, right? They don't go to work and say, I'm going to write 3 more lines of bad code today. That's my quota, right? Nobody sits there and thinks about writing bad code. We write bad code because we didn't even realize we are writing bad code. And you come to me and say, why are you doing this? I'm like, I don't know. I was just trying to make this work. Is this bad? Oh, it's terrible. You're going from there to here. Oh, you know what? Thanks. I didn't even think of that. Let me try to refactor this code. But what if you can give me a certain indicator? It's kind of like the modern cars, right? If you are driving one of the cars created within the past, I don't know, 3 or 4 or 5 years, you are driving on the road, you turn on your indicator, and what does it say? Hey, there is a car next to you. Don't change lanes, right? The light goes on, there's a little ting ting ting, and tells you, don't change lanes. That's dangerous right now to do so. Those are your checks. You're still driving, but they want to protect you from getting into an accident. So, as an architect, as a team leader, how do you say, hey, I don't want your controller to call the repository directly? And the programmer is like, thanks for the advice. I like it. Good recommendation. And you're looking at the code, right? I have a client, and we did the 4 days of course, and the 5th day they said we'll just go through refactoring. So I do 4 days of course. We talk about do's and don'ts. We talk about a lot of stuff, and then on Friday we said let's refactor. And right in the morning on that Friday, their architect sits down. The team is with us. He opens the source code. He opens the IDE. He is about ready to click on a file. And he looks at me and says, Venkat. I said, yes. And he said, we know. I said, you know. He said, yeah, we know what not to do. And then he opens the file. And exactly what we know not to do is what's in the file, right? And he looks at me and says, that's why we are here to refactor. We know not to do this, but that's what has been done. And like, why? Well, because somebody was writing code and they had to do this. Whether it's a shortcut, whether they were time pressured, where they just didn't realize. The problem is, you can have all the things written in a book. You shall not do this. You shall not do this. how do you enforce that? If you don't have a way to enforce it, you are going to keep looking at it over and over and over. You got to keep doing code reviews. You got to fix it. And the minute you fix it, what happens? It can go back to where it falls apart, right? So the question is, what can we do to take these constraints? As an example, how do I say my controller doesn't talk to the repository directly, as an example? I was working with a team, one of the developers said, hey, I want to know that only these kinds of exceptions are thrown from this layer of the code, and no other kind of exceptions are thrown. How do I enforce that? I'm like, gosh, that's a great idea. And he said, hey, how do I enforce only these implementations are, these interfaces are exposed? How do I verify my module exposes interfaces, my module exposes factories, but no implementation class is public? How do I enforce that? Those are architectural fitness functions, right? Because as an architect, you are saying, this is my boundary of my module. Here are the interfaces sticking out. Here are the factories sticking out. And all these implementations are private to the module. A programmer is sitting and writing code, public class implementation. Ding, 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 ding. I want to hear that bell go off, right? Hey, what's up? Oh, you made that public. You shouldn't. Why? Because we set an architectural constraint that you only release these things and not other things. That's a fitness function from the architecture point of view. Now, the first thing is to identify what these fitness functions are. Certain fitness functions can be automated. You can put them together and automate it. Certain functions are hard to automate. They're not impossible. Maybe they are, but they are hard to automate. But here is my first and foremost recommendation. This is amazing as a human being. If you tell me, do this, I'm like, oh my gosh, that's overwhelming. I don't think I can do it. I'm not capable of doing it. But I say, let me do the minimum I'm able to actually do right now. Let me find a way to automate this. And the minute I do that, my mind says, that's kind of awesome. You automated this part, but you learned something doing it. Oh, now I can automate that one. And the minute I do that, I gain a little bit more skill. Oh, wait, I can automate this one. It's kind of like climbing through these stairs, right? If I'm down there and you tell me, come over here, I can't jump on this. It's risky. I may break my, parts of my body doing it. But I climb the first step. I'm closer to the top. Second step. This is one thing that I realized over time is we in this room are unique in a way. If we go to a dentist and give them a computer is not related to dentistry. They're using computer as a tool. You go to an accountant and you give them a computer. They use the computer as a tool. We are different because a computer is a tool, but it's also what we program. We are special, right? A dentist, I don't think they do self-dentistry. That's not a good idea. They can't fix their own teeth. A surgeon doesn't perform surgery on themselves. We are special. We can fix our own stuff. We can even mess our own stuff, right? That's our capability. So it made me think, I cannot be using my computer as a novice. I got to use my computer differently. And so I asked the question, how can I automate things on my machine? And if I can automate things on my machine, then it's a skill I develop. And as an example, right? Very, very trivial example. I have a spreadsheet I have to update every week. And what I used to do about 2 years ago is every week I would open the spreadsheet, enter the data, save it, and then open the spreadsheet, and then delete columns I shouldn't expose because they are masked. Then click on the column that needs to be sorted, sort the column, and once I finish sorting it, generate a PDF file. Once the PDF is generated, push it to the server for application, and then undo all the changes in this file, and then walk away. 5 minutes, and then I make mistakes, 10 minutes. But above making mistakes, it's boring. It's boring, right? I would rather go to the dentist than to do that task because there's no intellectual activity. You open, you remove columns, you sort it, you generate PDF. And I said to myself, heck, I shouldn't be doing this. But I want to make. I said, what if I can learn how to do this with AppleScript? So I spent time learning AppleScript. I didn't know how to use AppleScript. I learned AppleScript. About an hour later, I've got a tool to automate this. So every week, when it's time, I say go, it goes to the file, opens the file automatically, strips the columns out, sorts it, generates the PDF, removes the file, brings it back a fresh copy from the version control, takes the PDF, remote logs into the server, pushes the file, and displays a message saying, I'm done. Can I help you with something else? Like, thanks. No thanks. That's all I wanted. So now I'm not wasting that stupid 10 minutes. I can do other things like sip a coffee and stare at the mountains or do other things. And that is automated. But the beauty is that showed me I can automate that and immediately led me to automate a few other things. And every week, oh, I'm doing this manually, but I know AppleScript now. I can automate this. And all of a sudden, you're on your way to automate several things. It's the same thing. In the beginning, it's intimidating. Oh my gosh, I don't know how to do this. I don't have to do all of it. Let me just take one step forward. Let me do this. Oh my gosh, that's working. I learned this thing. Now I can come back and improve my skill and keep going. So what if you are looking at an architectural constraint and you're asking the question, what if I can automate this particular check and write a fitness function? So step number one, identify the fitness function. Step number two, find a way to write that. You're like, I don't know how to do it. I don't know is liberating. Because the minute I say I don't know, what that means is I am willing to take help. You know what? I don't know. Have you done this before? It's like, yeah, in a previous project we did this. Great, can you show me? Now we can move forward. Hey, I don't know, but you don't know, but we both can talk about it and find a way to implement. So that is the first thing. Once you identify the fitness function, the next question is, how do we implement it? One way, right? Not the only way. One way is a tool called the Arch Unit. An Arch Unit is a tool that will allow you to write JUnit kind of test. Arch Unit works for Java. Arch Unit works for C#. So you can write tools, unit test kind of test. They're not unit tests, right? But just like you write unit test, you can write test and you can tell Arch Unit, hey, Arch Unit, here is my code base. And here are the different parts to it. And I want to implement a rule. I want you to go look at the repository. Look at all the classes in the repository. And look at who is calling it. If the one that's calling it is a service, good job, be quiet. If the one that's calling is not the service, but something else, report and fail the build. So now you're implementing an architectural constraint to say, if my code here is talking to the code over there, I want you to report it and fail the build. Because that tells me one of my developers was in a rush and implemented something that is outside of the constraints we have placed. So you can start monitoring these kinds of things. So where do you use it? You can use it as part of your continuous integration. So as an architect, step back for a minute. As a programmer, we talk about what's called self-documented code. What's a self-documenting code? You read the code and it explains what you do. But one way to self-document code is to use unit test, because unit test is a form of documentation. An arc unit test can be a form of documenting your architectural constraints. You can say, hey, on the architecture, we place a constraint that this code should only talk to these locally. It shouldn't talk to that. Great. Let's capture that as a test in our system, right? As an arc unit test. So how can we use it? You can run it as part of your continuous integration. So let's think of just one example, if you will, and see how this actually looks like. So let's take this example and just look through this for a minute, right? Let's see what's going on here. So I have an engines right here, and I have vehicles right here. So I got, so to say, two subsystem or two modules, right? So let's look at engines for a minute. The engines has this code. So what do you see here? You got a turbo engine that implements engine. So let's think about this a little bit, if you will. So I have a turbo engine, which is an engine, right? So we have an inheritance hierarchy. That's what we have right now. And what does a turbo engine have? It depends on a vehicle, right? So you have the turbo engine, and that depends on maybe an association, right? And it depends on a vehicle, right? So that's what we know so far. And then, so that's my turbo engine. What about my engine? Good news, engine is an interface, no dependency, right? Then you have a piston engine. Piston engine implements engine and depends on the vehicle, right? So what do you have? You have a piston engine, and the piston engine depends on vehicle also. Good so far, right? So that's what we know so far. Let's go to vehicle. In the vehicle, what do you see? Good news, vehicle is an interface, just like an engine is an interface, right? So what do you know so far? You know that you have a vehicle right here, and you know that these two talk to that, right? That's what you know so far. Then what do we know? You look at a truck. A truck implements vehicle. That's nice. And what does that depend on? Engine. What about a car? Implements vehicle. What does it depend on? Engine. So now we have a car, right here, and we have a truck. And what do these car and truck do? The car and truck are depending on the engine, right? So that we know so far. Question, what do you think of this design? Good, bad, ugly? What is bad about it? Cyclic dependency, right? Have you ever worked with a system where there are cycles? Yes? No? I worked in a system where we had cycles, and the cost of that is a compilation that could take 3 hours. We got to compile this, create a stub, put that over there, compile that, take that, put it over here, compile it. How did that feel? Terrible. You know why? I had to do it. That's why it felt terrible. If I had an intern, that's no problem, right? Hey, you do it. And the intern is so happy. This is great. What's great about it? I do stuff I don't understand. This is great, right? This is boring. You got to compile this, create a stub, put it over there. And you're like, my gosh, why are we doing this? Oh, because there's cycles in here. And we need to break it. So you can do after the fact refactoring. What if I can tell you cycles are bad, don't allow it? In, in things like Java modules, module system takes care of it. Your Java modules could be an architectural fitness function. Because a module system says, excuse me, no circles for you. Oh, thanks modules for keeping an eye on it. But what if I'm not using Java modules? What if I get cycles in it? Wouldn't it be nice to find it? So the first thing is to identify cycles, right? That's what you just did. But what do I want to do now? I want to say cycles are bad. Don't do it, right? That's what you're saying, right? So guess what I'm going to do now? I am now same code as you saw earlier with only one difference. Guess what the difference is? I'm writing right here, check cycles. This is our unit, right? Check cycles. So what am I telling check cycles? I'm saying, hey, go ahead and look at the class importer and import the package vehicles and the package engines, right? That's what I'm saying. Go import those two packages. Then my test, no cycles between modules. Slices, matching, calm.agile developer should be free of cycles, check classes. This is a skill, right? You're going to take the skill and write it as an architect. And if you don't want to write it as an architect, there's always an intern for an architect, right? And you say, hey, write that for me. And they're like writing this and like, let me run this and see how this goes. So that's your architectural function, right? Just to say, no cycle rules. This is just one example, right? This is not the only thing you can do, but it shows you a possibility of what you can do. So this says, no cycles. What good is this, right? If we cannot run it. So run it and see, hey, go run this test for me and tell me what you think about it, right? Run it. So when I run it, what happens? Did that pass or fail? It failed right there, right? The X mark with the red. What's the problem? Assertion error, architecture violation. The rule, slicing matching, should be free of cycle, was violated. One item. This couldn't be any simpler, right? Cycle detected. Sliced engine depends on vehicle, and vehicle depends on engine. Couldn't be better error, isn't it? It not only says there is a cycle, it shows you where the cycle is for that little effort. And most of the time, it's copy and paste this to write more code, right? Once you know how it's working, rinse and repeat. You can spread this across the teams. Dependency of cycle engines. And it tells you what line number that cycle existed from. Line number, right? Line number, whatever in that file where that was happening can lead you to that particular violation. So far, so good. What's the next step? What was that? Refactor, right? Refactor the code. So what are we going to do? Next step, let's refactor. So here is my refactored code. So what am I going to say? I want to remove those cycles as you rightly pointed out. So here's my engine. So what am I doing? In the engines, I have piston engine and I have turbo engine, right? What's missing? The engine itself. Similarly, here's the vehicle. I have car and truck. What's missing? The vehicle. Because the cycle came from the interfaces being used by the classes, right? So the cycle was like this. The implementation was talking to the interface, and the implementer was talking to the interface. Thank goodness, classes were not talking to classes, right? It was this way. So now how can I break the cycle? There are many ways to break a cycle. But I can take the interfaces, move them to a separate module, right? And if I do that, what's going to happen? Let's find out. So in here, what am I doing? And I'm saying there's an automobiles. And what does the automobiles contain? The automobiles contains engine and vehicle. Does that break a cycle? Right? Because we took this dependency and said, hey, this guy and this guy, let's move it up here. What do these two do now? They do this. Because they took the dependency and they took it out, right? It's one way to break the cycle. I refactored it. Well, once I refactor it, what's going to happen? I go back to that same test we saw earlier, no difference, right? Run the test. And when I run the test, it says you're missing this is sad, right? A semicolon is missing. That's what it's complaining. There we go, try that. I don't know how it got rid of that. So go back and run the test and see what does it say. So when you run this again, it says no problem, right? All test passing, test passed. So now this becomes part of your continuous integration. Every time you push the code into the repository, what are you going to do? Run for these validations. What can you check? A lot of stuff. Cycles, dependencies. Hey, am I exposing interfaces alone, or am I exposing implementation classes? You can verify that as well. Am I having dependencies by passing layers? You can put that in. And the beauty is this, right? You don't have to do all of that on one day. Get an infrastructure running. Do one test. Now you got a foundation. And you're sitting in a meeting. We need to really think about the constraint. Hey, I can make that a fitness function this week. Just add one more. 3 weeks later, we need a constraint like this. Oh, we already have a test like that one. Copy and paste it. Make some changes. And now you're building your fitness functions one step at a time. And these are running in continuous integration repeatedly, and you're able to enforce your constraints on your system as an architect into the system for verification. So chance of these being violated goes low, and you're able to get that feedback loop. So this is based on the async dependency principle, and dependency is RQunit unit, and you can analyze class, and you can implement it. And if you go to their website, pardon me, and you look at the user's guide, they give you a lot of examples that show you different kinds of things you can write. When one of my clients said, how do I do this? My honest answer to them is, I don't know, but I'll get back to you. And the next day I went back to them and said, here's how you do it. I'm like, oh, thank you. Now we can implement it. It took me an hour to research, think about, scratch my head. I'm like, oh, I can implement this now. It's not an example from the user's guide, but you put them together and now you have something working, right? And you can discover things. And that becomes a very effective way to do it. I hope that was useful. That's all I have. Thank you.